Imagine your house is throwing a wild party and electricity is the guest list. Everything's running smoothly, lights, music, dancing, until an uninvited guest, aka a voltage surge, tries to crash the party. Now enter the surge arrestor. It's the bouncer standing at the front door. When regular guests arrive, the bouncer lets them in without a fuss, but when that unruly surge tries to storm the gates, the bouncer redirects them to a safe place, like the ground, and keeps your electrical system partying peacefully. My name is Elena, and I'm a power systems engineer at Revamp, based in California, and I specialize in temporary overvoltage, or TOV studies. TOV studies can help us determine arrestor sizing to protect electrical equipment in the field against overvoltage surges. A surge arrestor is made out of metal oxide varistor discs, which are semiconductors that are sensitive to voltages. Little voltages across electrodes produce very small leakage currents, but with large voltages, the diode junctions break down and large currents are directed through to ground in order to clamp the voltages. In solar, battery, and wind plants, load rejections and unbalanced faults, especially in weakly grounded systems, are the main sources of temporary overvoltage spikes, and it's my expertise to study these events and their impacts on our designs. After the voltage event, the concern is how fast the overvoltage vanishes, either by fault clearance or inverter tripping. The longer it takes, the more energy needs to be dissipated by the arrestors. TOV studies focus on identifying the worst-case overvoltage conditions expected in the system. There are many contributing factors to measuring accurate overvoltages, so a detailed model needs to be created in an electromagnetic transient, or EMT program. At Revamp, we model the plants in detail using specific data received from equipment manufacturers. This includes arrestor VI curves, transformers, inverter EMT models with specific protection settings, and more. Timing is also important. When you apply the fault at different times, the transients can affect the worst case. Here at Revamp, we study all possible TOV scenarios and conduct point-on wave analysis to measure the worst case overvoltages. Another key focus of TOV studies is assessing whether the system maintains effective grounding under fault conditions, which is essential for ensuring safe operation and equipment protection. EMT modeling of inverters adds complexity due to their intricate control schemes, high-frequency switching, and interaction with grid conditions, making their dynamic characteristics critical in shaping fault responses. If overvoltages are miscalculated and arrestors are inadequately sized, there could be damage to equipment, so it's really important that our models and methodologies are accurate. Thanks for listening, and hope to talk to you in the future about TOV studies.